So a lot of the time, students try and work out little bits of a problem as they go. What we prefer to do is try and work algebraically. What that means is trying to make the solution up as an equation that we can just put values in at the very end. This has the advantage of us being able to see any mistakes that we've made or go back and see where numbers came from. It also means that we're not writing out numbers again if it takes several layers of working or several lines to get to an answer, and we're less likely to miswrite something or misrepresent or misread a number after we've written it out again and again and again. So algebraic working is a really good way to solve problems. It's also actually a lot quicker once you get your head around it. So if you've got lots of different things to try before you find the right answer, this is a much more efficient way of doing it. But it does take a bit of getting used to. Let's just take a quick look at this question. A 240 volt motor draws a current of 4.5 amps and lifts an object of mass 8 kilograms at a speed of 4.3 meters per second. Calculate the efficiency of the motor and the lifting system. Okay, so we've got to apply some of our problem solving ability to this, try and understand the situation, which again involves a little bit of a sketch. So we've got an 8 kilogram object. It's been lifted at 4.3 meters per second, and it's been lifted by a motor. I'm not going to particularly draw something that represents the motor, but I just need to make a note that it's 250 volts and 4.5 amps. So once again, we've got a few bits and pieces we need to understand. Calculate the efficiency. So the first thing I want to really write down is the equation for efficiency. You'll see a few versions of this, but basically it's useful energy over total energy, or useful output energy. You might see it over total energy or total input energy. And if you want that as a percentage, you multiply it by 100%. Otherwise, you're working in a fraction. Okay, what other things do we know? Well, we know this is something to do with energy. So I might write down the kinetic energy equation, half mv squared. I might write down the potential energy equation as it is being lifted up, which is mgh. Technically, probably should have the little deltas in front of those two as well. I'm also going to need to be able to bring the current and the voltage into this. So from the lab, eventually, either you already have or you will have come across this or you're about to, but you'll know that the power from a circuit system from a voltage and a current is found by IV, where I is the current and V is, of course, the voltage. We also know, therefore, that energy is power multiplied by time. We know this because power is energy over time or work over time. So putting all those things together, we also know that the energy supplied by an electrical system is the power, which is IV, multiplied by the time, so it's IVT. Okay, so this gives us lots of starting points. I might not need all those equations, but I've got them there and I can see what's going on. So the first thing to do is realise that it's the efficiency that I actually want. And what I'm going to do, because I've got a bit of a word equation here, I'm just going to call these EU and ET. So I'm putting a little bit of notation in, which is going to make life a little bit easier for me. So I'm going to start with an equation. Again, this all comes into problem solving, just starting somewhere. I've got the efficiency equals the useful energy over the total energy. So the useful energy output, I could have called this EO, it wouldn't really matter. The useful energy output. The output is, well, it's been lifted, so the useful energy is GPE. So this is the gravitational potential energy. The energy total, this is the energy input, is going to be electrical. So that gives me somewhere to go with my equation. Now, the temptation at this point is to go, right, well, the GPE is MGH, so I can work something out for that. The electrical is IVT, I can work something out for that. But you're going to come unstuck quite quickly trying to do that because you don't have all that information. But if we go algebraically, we can look at what we've got and see what we can do with it. So if I say that the GPE, well, that's mg delta H, mass times gravity times change in height, and the total energy input is IVT, then I've got something I can work with. Now, unfortunately, I've got a bit of a problem here. I do know the mass, I do know g, I don't really know a change in height, but I do have a velocity, so yeah, okay, that doesn't really help me. I've got a current, yes, a voltage, and I've got no sense of a time really at all. But wait a minute, what I can do is I can look at the problem I've got in front of me. I could go down a completely different path, maybe, yes, but I could realise that if I've got the quantity of distance divided by time, that gives me a velocity. And a velocity I do have. So h over t, the rate of change of height, if you like, I actually have as a value. So for one thing, making the equation up makes it a little bit easier to do things like that. So now all I've got to do is put in the correct values. So 8.0 multiplied by 9.81 multiplied by h over t, which is actually 4.3, divided by 4.5 multiplied by the voltage, multiplied by the time. That was part of the 4.3, so I don't actually need a value there. Okay, fair enough. And the rest is now very easy. I can just shove that in a calculator and I've got an answer. The reason why this is an advantage is, let's just say that maybe the voltage was a millivolts, for instance, and I accidentally put 240 in, but in millivolts, and I didn't convert it. This is a really easy thing to do, and it's also a really easy thing to check if what I've got is my workings out written down here, because I can see what each of these numbers represents. If I'd worked out what MGH was first, and maybe, okay, I'd come up with a way to do that and done it over a second, for instance, so I know what the distance would be and t would be 1, I could work out MGH, and I could work out IVT, and I could have done it that way. But if I'd made any mistakes, I would have found it much more difficult to go back and find them. I would have had to have started from the beginning. So working algebraically is a much more powerful way of problem solving, especially if it's multi-stage and you need to step away to see what you've done and then come back. You might not necessarily really understand where you got to. This is a good way of keeping you working organised, but it's an excellent way of spotting mistakes.